Hello, am I audible to everyone?
Yes, sir.
Yes, okay. Now I'll start demonstration about one application software which is further useful for us regarding our research project, that is digital plot digitizer. It is used for getting the values from any graphs, images which we have in the form of graphs. From there we can extract the values in the digit form. So this is very helpful for us in the future. So for this app, first I have to share my screen. This is your app, WebPlotDigitizer. It is available in both if you are working in Linux as well as in Chrome. You can download this application online from online, and the basic use of this is to just this is the image in which you having which are having graphs. You can just get the values for each and every point of this graph in the form of Excel file or sheet, which is furthermore required for this in your other applications in machine learning and AI. So for this, what you have to do, you have to download research paper from IEEE. For example, I have downloaded this paper. For example, I have downloaded this paper. Any paper you can download. So if you want the values in digit form for any graph, for example, if you want the digital value for this graph or this graph, you have to just copy this image from this paper and save anywhere in any folder in which you want the digitalized values. For example, for this figure, I have just copied these two images. This is one image, and this is second image. Now, once you have this image, you can get this graph. You can get the digital values for this graph. So I will demonstrate a fresh image for you. This is the image in which we are having three different graph plots in a single image. So we can get the digital values in the form of Excel sheet for all these three graphs. What you have to do, just go to this software. Here in the file, you can go to load image. Choose the file which you want to choose. For example, our file is in downloads, News 7. This is our image. So this is basically these have many types of graphs you can or images you can use here. We are using a 2D plot which have x and y coordinates. So align axis. So since this is a 2D graph, so we have to access x axis and y axis. We have to align 2 points. That is starting point for x and end point for x. Similarly, starting point for y axis and end point for y axis. So we'll proceed. So using this cursor, you can place the point from where your axis is starting. So this is the zoom version of your this image. So if your starting point is 0, so you should place your x1 right here. Similarly, your end point is here. This is 0.8. It is approx 1. So just put your x2 point here. So you have given two points for in x direction, that is x1 and x2. Similarly, your y point will start from this point y1, and it is going up to 9, 10. So for safety, we can choose it 12 or 11. You can choose any point. So I am choosing it 12. So these are our coordinates. Now once you align this point, you can actually, if the point is not appropriate from the cursor, you can move and made it accurate. Now after that, you press complete. Now it will ask what is your starting point of x-axis and end point of x-axis. Similarly, what is your starting point of y-axis and end point of y-axis. So our starting point of x-axis is 0, and we are going up to 1. So this point 2 is 1.0. Similarly, starting point by y-axis is 0 and it is going up to 12. Now you have aligned the axis. Next point is to add the point. So for example, if there were not three graphs, only single graph was there, so you should directly go to this add point and just mark the points in this single graph, and you will get the CSV file. Now there, since there is three graphs, so we have to add data set for each and every graph. So here we can go to data sets, add data set. So whatever the name of graph is given is here, you can give the name of your data set. So first is 327 is red, so 327. Add single data set. So this data set has been added. Now click on this add points. Now you have to add points to this red. So just place the cursor on the red point and start adding points. First randomly click for the points. Now, after adding points, if any point is missing from that graph, you can adjust this point. Just look at that. This point is, you can just click on it, select it, and using the arrow key, you can move it in the center. This one. This point is outside, so just select it and bring it to the graph. Similarly, you have to put multiple points so that you can get more values for the graph. Again, this graph is completed. Now you have to select the points in this green graph. Again, you go to data set, add data set, give the name 302, 302, add single data set. This is 302. Select it, add data point. Now the third one is 300. Again, data sets, add data set, 300, add a single data set, select it, add points. Now again, if you want to adjust a point, adjust point. This point is out, just move it inside. Now this default data set is nowhere will not require this default data set. So we can delete this data set, delete data set. Okay. So we are having three different graphs in a single image. This one is red one is 327, green one is 302, and this blue one is 300. So we will get three different rows and columns for these three different IV characteristics of this plot. For this, you have to just go to the export data. You'll get it in form of download in CSV format. So just download it. Give the destination, whatever name you want to give. Okay. So this is the digit values of our graph. For 327, this is our IV. This is our x-axis and y-axis value. Similarly, for 302, this is our x-axis, y-axis, and this is 300. This is our uh, x-axis and y-axis. Try to make this data points equal for all the three regions. In this way, you can you can convert your graph in the form of tabular form of Excel sheet. So what you have to do for you, the assignment is that you have to just download three papers, 3 to 4 papers from IEEE Explore, which have experimental result on tunnel diode. Which have experimental results on tunnel diode. You have to just download that paper, and from that paper, whatever the IV relation graphs are there, you have to convert that graphs in the form of this CSV files, and make separate folders for that. For example, I have done for 7 different papers. So I have made this 1, 2, 3, 4, 5, 6, 7 for different papers. It should each folder should contain this CSV file, and whatever the graph images you have converted into for each image you have to convert one CSV file, and the whole paper, whichever paper you have used, that whole paper you have to. For example, this paper I have downloaded, so it has one IV relations, 2, 3, 4. So all the IV relations you have to just convert it into a CSV format file, and make one folder. So each